Okay, so good day again, everyone. So in this video I will be covering differentiation of trigonometric functions and logarithmic functions. So let's just get straight to it. So I'm going to write down the standard results for differentiating various trig functions. So as I mentioned in a previous video, if you differentiate a sine function that result is just cosine of x. If you differentiate cosine, that gives you negative sine x. If you differentiate tangent, tan x, and that is sec squared x, and sec squared is secant x, secant squared x. That's what that means, secant. So cos is cosine, sin is sine. We say sine, not sin. And sec means secant. Right? If you differentiate, and what I should also mention is that secant is the reciprocal of cosine. So if you should reciprocate, let me start with sine. So 1 over sine x is equal to the cosecant, cosec x, and 1 over cos x is equal to sec x, secant x, and 1 over tan x is equal to cot x, or cotangent. So that's cotangent, secant, cosecant, right? So now let me continue. If you should differentiate the cosecant, that's equal to negative cosec x cot x. So that's cosec x multiplied by the cotangent of x. Cosec x multiplied by the cotangent of x. I'm just using different colors here since the letters are very close to each other. Okay, if you should differentiate secant x, that is sec x tan x, and let me come over here. just separate this. Okay, if you should differentiate the cotangent of x, that will be negative cos x squared x. Okay, good. So you have the derivative of the trig functions and also the derivative of their reciprocals, right? So these are stuff that you should try and memorize depending on your level of mathematics that you're doing in school right now. You may only need to remember the first three, but it's always good to remember them. They may come up eventually. And also the reciprocals, ensure that you know that cosecant is the reciprocal of sin x, and secant is the reciprocal of cos x, and cotangent is the reciprocal of tan x. Okay, so with that said, we can jump into some examples. Okay, let me clear the screen. Ensure that you make note of these. Okay, great. Now for an example problem. Okay, let me see. Okay, let's write this. X to the 7th power minus tan x. Good. Now we want to differentiate that. Okay, so that's simply equal to the derivative of x to the 7, which is 7x to the 6th power minus the derivative of tan x, which as we know is x squared x. Good. Let's say we're asked to differentiate okay, let's say sin x times the cosine of x. Great. Now as you can see, this is a product, and we have already learned the product rule, so we can apply it here. The product rule states that it's the first, which is sin x in this case, times the derivative of the second, which in this case it's cosine. The derivative of cosine is negative sin x plus the second times the derivative of the first. The second is cos x, and the derivative of the first, which is sin x, the derivative of sin x is cosine x. All you need to do now is simplify, so that's negative sin squared x plus cos squared x. Alright, and we can put the positive one first. It doesn't really matter, but that's just my preference. Okay, and when I get into some trig identities, you will see that that result could actually be written as the cosine of 2x, but as I said, when I get into trig identities, then I'll cover that. But just in case you have an idea of trig identities, then this would be simply the cosine of 2x. Okay. Alright, but you can always leave it as cos squared x minus sine squared x. Let's clear the screen. Okay. Now, what if we had, let's say, alright, the sine of 2x, good, multiplied by x squared. So what if we had x squared sine 2x, and we are asked to find the derivative okay, sorry for my bad handwriting. Yeah, that's atrocious. Anyway, so as we know, this again is a product. We're just practicing to apply the product rule. If we should differentiate that, so let's say d dx of x squared sine 2x, again that would be the first times the derivative of the second, which in this case the first is x squared, so let's say x squared times the derivative of sine 2x. Now if we remember from the previous video that sine 2x would require using the chain rule, and I also showed a shortcut to using the chain rule, so you can go back to that previous video and check out the chain rule if you haven't done chain rule as yet. Okay, so let me proceed to differentiating the second, which is 2 cos 2x. Good. Now plus the second times the derivative of the first, and the derivative of the first is 2x, so that's 2x times sine 2x. Okay, great. Therefore, you can simplify that, so that's 2x squared cos 2x plus 2x sine 2x. Now of course you could factor out a 2x here if you, and that's if you want to. Okay, let me do that. So we could factor out 2x, and okay, so what would be left here is x cos 2x plus sine 2x. Okay, we can leave our answer as that. Now that's basically there's not much to trig differentiation, I guess, as long as you know the standard results that were given in the first part of the video. All you have to do is remember them and apply them to whatever problem you're working with. So you're going to have cases of the product rule, the quotient rule, the chain rule. Doesn't really matter. Okay, let me do a problem here, another chain rule problem. Let's see, I have tan let's see, tan of okay, the tan of sin x, right? Good. And we're asked to find the derivative of that, the tan of sin x. Good. Now what we should remember is that if you haven't yet done chain rule, go to the previous video and learn about chain rule, then come back to this one. So as I said before, you would differentiate tangent to get sec squared. So the result is basically sec squared of sin x multiplied, and all of this will be multiplied by the derivative of sin x, which is cos x. So your result should be cos x sec squared sin x, right? And this could be simplified if you want. Again, that decision is up to you. It doesn't really have to be, but let's do it either way. We know that secant is 1 over cosine. So if we have that simply means that sec squared is and on second thought, that cannot be simplified any further. I was that was a mistake actually to say that. Anyways, let's move on to another problem. Okay, so D, let me get away from the corner here. Okay, so d dx, let's do another problem. D dx of sin x plus x cos x minus x squared sine of x cubed. Let's use x squared. Good. And we're asked to find the derivative of that. Good. So as we know, we would differentiate each term separately. Okay, and let's do it at the bottom here. The derivative of sin x, that's just cos x, and the derivative of x cos x, now that's a product, so we have to use a product rule, and that's the first times the derivative of the second, so that's x times the derivative of cos x, which is negative, let me use square brackets, negative sin x. Good. plus the second times the derivative of the first. It's cos x. The derivative of x is just 1, so that's just 1 times cos x. Now we have minus the derivative of x squared sine x squared. Good. Now again, it's a product rule. Have the negative sign there. Now it's the first times the derivative of the second, so that's x squared times the derivative of sine of x squared. Now again, this requires a chain rule. So the sine of x squared is, if you differentiate sine, you're going to get cosine. So that's basically the cosine of x squared multiplied by the derivative of x squared from the bracket here, which is 2x. Differentiate x squared, you get 2x. Okay, great. So that is the derivative of sine x squared. Let me write that better. Okay, so that's 2x cos x squared. Now we have our plus the second times the derivative of the first. Now the derivative of x squared, that's just 2x, and the second is sine x squared, sine of x squared, so that's x squared in the brackets. Okay, close our bracket. So therefore that is the derivative of sine x plus x cos x minus x squared sine of x squared. Okay, so let's check. So we differentiate sine x, and that's cos x. If you differentiate x cos x, that's using the product rule. So it's the first, which is x, times the derivative of the second, and that's negative sine x, negative sine x, plus the second, which is cos x, times the derivative of x, which is 1. Good. So that's correct, and that's correct so far. And we maintain our negative sign. Then we differentiate the x squared sine of x squared, and the first, which is x squared, times the derivative of the sine of x squared, which is 2x cos x squared, plus the derivative of x squared, which is 2x, multiplied by the sine x squared. And also this is correct based on the product rule, so hence that is the derivative of sine x plus x cos x minus x squared sine of x squared. Now let's clear the screen and do another chain rule problem. This time it will involve the trig function being raised to some power. Okay, so let's say we have the sine squared x. Okay, simply sine squared x. Now we are asked to find the derivative of sine squared x. Now again, this is a chain rule problem. We can look at sine x as being, let me just rewrite this, as being sine x squared. Good. So saying sine squared x is basically saying the sine of x squared. Likewise for sec squared, cosec squared, tan squared, cos squared. That's basically the basic gist of it. Okay, now let's proceed to differentiating sine squared x. Now that is equal to, and again we are using chain rule here. So we are going to, okay, let me do the actual chain rule, or state it. Remember, it says that if you have y equal to f of x, then, sorry, if you have y equal to f of u, where u is a function in x. Now, u does not have to be in x. I'm just using x for this particular explanation. It could be a function in terms of t, b, c, a, whatever variable is being used. But just to have a general understanding, we're using u here to represent some function and x to represent the variable. Right, so this is basically a function within a function. So we have a function u, and that is within this function. Okay, and how you differentiate that? So dy dx would be equal to f prime of u multiplied by du dx. Okay, so let's just apply this to the problem now. Based on the problem we got up there, let me rewrite it here. D dx of sine squared x. Good. Based on that, our u would be equal to sine x. Good. Therefore, y would be equal to u squared. Since sine x is u, then, and sine x is being raised to the second power, so therefore y would be u squared. Okay, and let's just proceed to applying the chain rule. Okay, so dy dx would be equal to f prime of u. Now f prime of u simply means to find dy du here. dy du, which is equal to 2u, and du dx, let's just find du dx at the same time. Du dx is simply cos x. Okay, great. So let's just plug those in the formula. So that's f prime of u, which is 2u multiplied by du dx, which is cos x, and let's just back substitute. So remember that we let u equal to sine x, so we're going to plug sine x where u is. Therefore that would be equal to 2 sine x cos x. And again, if when I get into trig identities, 2 sine x cos x is something that you would come across, because that is also equal to sine 2x. So this is an identity. Sine 2x is equal to 2 sine x cos x. So you can also make note of that, and I'll see you in another video. Thanks for watching. Please like, comment, share, subscribe if you haven't already subscribed, and remember to give feedback in the comment section, and also drop your video requests in the comment section. Okay, so see you in another video.